representing our FEDD group project for the fall semester 2014. I'm Drew Schweikert, I'm the manager.
I'm David Jones, the modeler.
I'm Jen Lee, I was in charge of the materials procurement.
I'm Meghindra, I'm the designer. I'm Sriram, I was the point of contact.
And we are
the Raleigh project.
Alright, so the main type of radiation which we learned about through our project is known as Cherenkov radiation. First discovered by Pavel Cherenkov in 1934, Cherenkov radiation is the bluish light that can be seen from the nuclear reactor when there is water used as a medium. The cause of this eerie blue glow is due to the movement of particles inside the reactor. All particles in a vacuum cannot exceed movement faster than the speed of light. However, when in a medium, such as water, these particles are able to travel slightly faster than the speed of light, thus radiating a blue glow, an effect similar to the Doppler effect with sound waves.
Hi, my name is Meghindra and I'm from the Raleigh project. I'm the designer of the group. So the basic design of our group is pretty simple. We have taken two pipes, actually a 10-foot long pipe, which we have cut into two pieces like this, and then we have attached a glass at the beginning of the pipe that is here, and we have taken 6 wires, each attached to one photoresistor that will later measure the amount of light coming out from the nuclear reactor. So that will be converted into volts by the voltmeter, and from which we can actually calculate the power given out by the nuclear reactor. So the design was pretty much like this, and the pipe would be 10 feet long and attached like this. And basically how this thing works is the photoresistors are placed near the glass that is here, and these resistors pick up the light given out by the nuclear reactor. So as I have already explained it to you, the nuclear reactor wire. So these are the photoresistors I have shown to you before. They would measure the amount of light given out by the nuclear reactor, which would be in the water. So we had to put water sealant so that water would not seep in, and the resistor, we won't have a short circuit problem. So the light given out will measure the amount of light given out, and which would be converted into volts by the voltmeter, and thus from which we can calculate the results.
The biggest design challenge that we faced was when making our nuclear probe was preventing the water from actually leaking into our probe. Now this is very important because if water leaks into our probe, then we won't be able to get accurate measurements. So, and we knew this was going to be a problem to begin with because we looked at previous years' FEDD project videos on YouTube, and we found out that this was the biggest problem for almost all of them. So what we did was we actually tried to prevent this by putting an excess amount of water sealant that connects the plexiglass to the PVC piping, and you can see right here. However, ultimately we failed on that, and we did not get accurate measurements, unfortunately. But another problem that we also faced was how we were going to actually connect the wires with the photosensors. And with that, we had two options, which was parallel or series circuit. But a senior in nuclear engineering recommended a certain way of doing this, and we connected two wires to each ends of the photosensors, as I will show you in a minute, which looks like this. So with that, we had 3 different photosensors, and we were able to take the average of the 3 so that we would get more accurate measurements.
Hi guys, this is Sriram again. Regarding the FEDD project of the nuclear probe, I don't say exactly our project failed, but it didn't work out pretty well because though we tried our level best, we couldn't make the probe entirely waterproof or the water resistant. The thing is, we actually tried it when we actually constructed the probe in the beginning. We put it in tubs of water for a couple of times, but nothing. Absolutely no water went inside, but don't know what happened. But on the final day, when we were actually testing in the Burlington lab, the water went inside. Maybe what one of our teammates says is luck wasn't in favor of us. But if we were given another chance to do the same, we would make sure that the only thing we would make sure that it becomes water resistant. Maybe we use another add-on or use a very good water sealant, or let the water sealant be dried for a longer time than testing it immediately. Maybe that might be one of the reasons we actually gave a day of we actually spent a day for it to dry, but probably that wasn't sufficient. Yeah, that's it. The only thing that we would change is make it more waterproof. First of all, the wiring, the piping, the fixing, the joints, everything came pretty well. Yeah.
Hello, David here with how the Raleigh project fared at the Freshman Engineering Design Day 2014. First, I'd like to congratulate all the competition. There are some very impressive designs that had a lot of effort put into them. So we thought we talked to the judges well and left a good impression. We were able to explain our design process very thoroughly and what the probe was meant to do. In the end, though, we didn't place as high as we would have liked, most likely because of the high percentage error that we received when calculating the power of the nuclear reactor. Hello. I'd also like to talk about the advice we give to future engineers of next year who must complete the Freshman Engineering Design Challenge. So, with the nuclear probe, one of the biggest things we can say is start early. When you start early, you're able to test more and make more adjustments to your probe. And it also gives you more time to go out and buy materials, which can be kind of a struggle when you're cramped on time, to make time to run errands. So this kind of goes hand in hand with the make time is test, and test some more. Test as much as possible. That way you can assure that your nuclear probe will be waterproof and can function on the day that you must actually put it in the reactor. Although we tested, we didn't test enough, and on the day our probe did leak. Unfortunately, that could have been fixed very easily if we had just tested more than just once. So, along with testing goes the sealing of the nuclear probe. Use a very solid water sealant in order to secure the lens onto your PVC piping. We used a silicone sealant that worked okay, of course, until we tested it. There might be better options, though, such as a foam or a caulking. There's also many groups who use multiple stages in their probe. This made it easier to attach the lens to and from the probe and adjust all the sensors. They put it on the end where they could easily remove it and make any modifications necessary. We, however, just put the window, the plexiglass, right on the edge of the piping, which made it very difficult to adjust the sensors and move them around to get them into the correct position.